Yeah. Well, hello. Is this thing on? Okay, cool. It's on. So, first off, I didn't expect this many people to be interested in information security. And when somebody says something interesting like, let's fix authentication, authorization, people are usually not that enthusiastic, you know. But hey, for those who don't know me, my name is Tonimir. I'm a former tenured assistant professor and lab head, which, well, that career was boring, so I decided to go all out entrepreneurial. So I founded a small boutique AppSec consultancy where we focus on application security, IoT, and areas of architecture, implementation, reviews, and trainings. So that's the focus of my consultancy. Now and then, I like to contribute to popular open source security tools like Metasploit, Empire, John the Ripper, and so on. I co-lead OWASP for Croatia, and I do like to write a lot of standards, so this is still something I now and then like to do. I tweet on Kisasondi, or you can follow the consultancy's Twitter on OroInfoSec. First off, why should you listen to this? Why this should be interesting for you? Well, like a month ago, we got a new OWASP Top 10 for API security. And most of the applications we see today are some form of APIs. And first, vulnerability in almost, this is a standard that I see in all organizations. Number one, broken object level authorization. Number two, broken authentication. Number 5, broken function level access control. Number 6, mass assignment vulnerabilities. Those are the bane of today's, most of today's applications. And this is something you will find more commonly than some other vulnerabilities like cross-site scripting. Okay, cross-site scripting is still very big, but like SQL injections are not that common today because everybody knows. Who doesn't know what an SQL injection in here is? See? We pretty much solved one bug class. We have a couple of thousand others to go. If you look at what Google is paying money for, what their reward vulnerabilities program is giving out, they pretty much 35 of all reported bugs are cross-site scripting. I was thinking of, I think I actually submitted a talk on only cross-site scripting, which didn't get accepted, but too bad. Cross-site scripting is very interesting because it's way more complex than you think. It's a combination of multiple parsers. The way those parsers work, the way they interoperate yields some very interesting vulnerabilities. And like 49% of the vulnerabilities that Google sees on their systems is mobile app vulnerabilities, business logic bugs, and network level misconfiguration. So authorization, authentication, sensitive data exposure, this is like half of the bugs we see. And this is pretty much true today. Common misconceptions. One thing I see most often is when I ask people, how did you solve authentication? How did you solve authorization? I get, we use X epsilon for authentication. How did you solve authorization? What do you mean authorization? We have a login page and we store passwords with bcrypt or scrypt. Yeah, okay, I get it. This is authentication. How do you solve authorization? And then usually silence steps in. So authentication is verifying an identity of the object. Is this user, is this API endpoint the real one we're talking with? Authorization is defining access to an object according to somebody's authentication. That means, can this person access this object or this endpoint? Does he have the privileges to do so? The big problem with authentication is a large part of it is outside developers' control. So you cannot really select what kind of passwords your users will be using. You can enforce them with some complexity level, but all in all, it's outside of your control. And authorization is a large attack surface. I'll get to this in this talk. So one of the most popular things is some people collect Pokemon, some people collect old guitars, but hackers collect password dumps. So why do they collect password dumps? Because every day we see some site breached, thousands of passwords leak, and what do the hackers do? The white hat hackers, like the ethical hackers, they collect them and then inform their friends, anybody they know that won't get their mail wrong. They tell them, hey, change the passwords. If you're using these passwords, please do something about it. They are leaked. And the breaches are pretty big. Like for Croatia, there is about, that's not all the breaches, that's just some stuff I found lying on the internet. But for Croatia, it's 500,000 unique identities. For the whole wider world, it's 2.5 billion unique identities. And when you look at how many credentials have been leaked, we're talking about billions of usernames, passwords that are simply out in the open, like Collection One, like LinkedIn, MySpace. Yes, you can find my old MySpace password. It's embarrassing, but hey, it happens. So what usually happens is that this gets used in something called password spraying. How password spraying works is that an attacker will take those, for instance, when Collection One came out a couple of months ago, they take those usernames and passwords and then try them against PayPal, eBay, Google, any privileged account they think they can use to exploit or gain some other access to some services. And this is something that's happening widely all over the internet. But what people don't get is that in targeted attacks, we see those same credential lists used against systems. Why? Because if you have a company, or if you have a startup or whatever, this here doesn't reek of somebody knows what they're doing. This doesn't show deliberation. This just shows, oh, somebody reused the password and they got access. Because if you use some kind of very high-level, complex technique, something like a nation-state adversary would use, or something like a very skilled hacker would use, you can always say, oh, that's somebody who knows their stuff. But if you use a breached account, nobody knows what you really want to do. And we see this happening all over organizations. So keep in mind, the leaked passwords are a pretty big thing now, and they get used against targeted organizations. This is a site called Have I Been Poned? You can pretty much get all of those. You can verify for any email address if it's in there. But what's interesting is that you can go to Have I Been Poned passwords, and you can download torrents of hashed passwords, unique passwords, that are ordered by either prevalence, so how common a password is, or ordered by hash, so it will start with 00000 and then go down. Why is this important? Because you can use those dumps. There are even examples on GitHub where you can use an algorithm called k-means anonymity, where you just search for the first five bytes of a hash and see if it is contained in this file. So you can use this to verify if a certain account uses a password that is commonly used or breached, because attackers already use this word lists against other systems. So start thinking about that, start implementing that. Okay, Have I Been Pwned also has a service, but you don't need to use their service. You can just simply download the word list, get a microservice from GitHub that does the same thing and run it locally. So this is also a good thing to protect the users against themselves. And with this note, how do attackers approach systems for authorization authentication? Any attacker thrives in complexity. So what developers or system administrators call abstractions, layers, microservices, we call them attack surface. Because this is everything that gives us, how should I say, more leverage into various services. The more objects, the more functions, the more attack surface you give to your attackers, the more you enable them to find something. That's also a common problem in modern infrastructures. You have layers upon layers upon layers of services. You have AWS, you have 50 services in AWS, you have Kubernetes, you have 75,000 libraries from Node.js and NPM getting pulled into your whole project, and then it's a large attack surface. And the success that attackers have is there not because they're very smart, because they have a superpower. Do you know what this superpower is? Reading with comprehension. So you get the documentation for something, you read stuff, you figure out how it works, and then you see where common screw-ups can happen. So attackers just read with understanding. This is a thing people forget. And second thing what people forget is that they don't guess. they enumerate. It is trivial to enumerate an API endpoint, subdomains, S3 buckets, vhosts, DNS entries, and find new hosts. Okay, it's nothing interesting. It's just a tool called GoBuster, which you can use to enumerate any number of domains. But I still need a word list, right? I need still some sort of that. But security professionals, on the other hand, also curate security lists that can be used for discovery of DNS, of infrastructure endpoints, SNMP, web content, API endpoints, common parameters, and those give you enough to discover almost anything. So don't think if something is hidden, if you didn't list something somewhere that people cannot find it. They can find it pretty easily. Keep that in mind. And also, there is a common enumeration of naughty strings. And what are naughty strings? Imagine giving edge conditions for various sizes of, let's say, various special numbers, maxint, big int minus, big int divided by 0, RTL languages, Unicode languages, anything, any parser differentials that might trigger your JavaScript engine to just simply drop everything it's doing and call it home. Also, string formatting issues, all of that is pretty much available. With that, attackers will use those lists to fuzz your services and discover bugs. And with that, let's go a little bit into authentication and authorization. So first, a public service announcement. SMS two-factor authentication needs to die. And if you're using SMS two-factor authentication, please stop today. There are way better things you can use, and I wouldn't want you to use SMS. Why? Because when we talk about SMS two-factor authentication, people think that the real threat model is something cool, like something like SS7 interception. What's SS7? See, the telecommunications networks were created in the 70s and the 80s by a committee of people in Europe, GSM protocol, where one of the big discussions was how big should the keys be? So some members, like the US, decided something like 40 bits should be enough for everybody for legitimate purposes, because that would enable them to crack the keys. But West Germany said we need 64 bits to protect us against our neighbors. And well, then some kind of consensus was reached about 50-something bytes. Crypto there doesn't work. And also routing on that layer, imagine BGP on normal IP. BGP is something you use over the internet, but on mobile you use SS7, which is unauthenticated. Any telecom that has access to that network can reroute any SMS, any phone number, can do pretty much anything they want. So consider this warning. Even if you have something like 500 euros of money lying around, you can buy an SS7 access from a shady telecom in some country, and you can reroute any SMS from any number. For even cheaper, you can spoof any phone call, spoof caller ID, spoof SMS sources. The fun just keeps giving. SS7 access is very fun. But this is like high tech. This requires 500 euros. The worst thing is that we have something called SIM swapping. But what is a SIM swap? When you come to a mobile provider, like their shops, they have those little centers where you can buy phones, buy SIM cards. If you buy a phone, or if you social engineer somebody to swap your SIM card because you just bought a new iPhone and you need a mini SIM or a nano SIM, or just I got this new iPhone and can you please swap the phone number for, can you swap the SIM card for the new one? They will happily issue a new SIM card. So what will happen? Your mobile phone will stop working and all the calls will be sent to the new SIM card. This was used also to hack Jack Dorsey, like I think a couple of months ago. So they didn't use any high-profile technical hack. What they used was social engineering somebody into allowing them to swap a SIM card for that. Also, if you use SIM SMSs for password reset, that's a whole nother problem, because you get an SMS code, which is 6 characters or 8 characters, which you can brute force over an API endpoint in like 10 minutes. You can just simply, first off, you're going to bomb somebody with SMSs, and the short key space for that code, if you don't have throttling. And remember, throttling is one of the very common. Yeah, that's a problem. See, the machine is secure. I cannot use it at all. So the throttling is also like number 3 or 4 on that list because people don't throttle their API endpoints. For technical people, you can secure an email account way better, and most of the people would be way better off with email-based two-factor authentication. Why? Because this is what we have today. You can get some code out of GitHub called Evil Nginx 2, Modlishka, or I forgot the third one, which you can load them on any public cloud instance. They're written in Go. Golang is awesome for offensive security. They'll issue themselves, they will request a Let's Encrypt certificate, and they will set up a proxy. So how this works is, this is actually a page that is not a phishing page, but you're connecting to a proxy, which will give you something that looks like a valid page, but it's actually on your domain. And when you enter your username, it will pull out your profile picture. If you enter a wrong password, it will say wrong password. If you enter a correct one, it will, of course, give you a correct one. And then if you want to add, if you have two-factor authentication, it will ask you, oh, we just sent an SMS to your phone number, please enter it. So everything will look authentic. This also works for TOTP tokens for anything except U2F, like security keys. So phishing people, even if you do a little bit of pretext, is very easy. And it's not something that like nation-state adversaries do. There are open source projects on GitHub that you can use. This is something that we see a lot more often, and U2F is the only way we can fix this. And FIDO2 is also a newer version of authentication protocol that is used to mitigate this. By the way, I'm going to tweet out the slides so you can get it off Twitter later, any of those links. Please do not use any of this for evil, of course. So how do security keys work? A security key gets paired with a service, and it generates a elliptic curve key. It stores it in the security key and sends the public key to the service. So when you come to any site and you want to authenticate, the server will send a challenge, and your browser will send the challenge, and the origin, so which page is requesting authentication, which domain. So your YubiKey or your Titan key or your Phaeton key or any other U2F or FIDO2 key will prevent any of those phishing attacks, like those U2F phishing attacks, not U2F, second factor phishing attacks, because they won't be able to authenticate to that service because, of course, the origin of the request will be different than the genuine server. And then they will just sign the request. They will sign the request with the key that's stored in the key. U2F or FIDO2 keys are awesome. They can hold multiple asymmetric key pairs. They have no shared material. They are privacy supportive. Logins are always bound to a specific page, so you can't spoof it, like in those phishing attacks. And also you can do a lot of other security stuff. So please stop using SMS. If you're using SMS, switch, if you cannot, switch to TOTP, timed one-time passwords. They're way better than SMS, but still phishable. And if you can, start with U2F. Of course, have backups, because if a key dies or you lose it, you need a backup one, okay? FIDO2 is also way better. If you can get FIDO2, they are more modern, and they also do federation. So you can, like, in the future, you're going to be able to relay everything through Google or to your own provider, so you can authenticate all of those services through a central. You won't have to enroll your key onto multiple services. Let's talk a little bit about authorization. A very common thing we also see is authorization failures. The object-level authorization failure is something we call insecure direct object references. So what's an insecure direct object references? Imagine you have an API and you want to get invoice number 123. What happens if you change 123 into 124, 125, 126? Maxint, -1. You start issuing octal numbers, you start issuing hex numbers. and so on. The same stuff applies to any other requests. Is it JSON? Is it XML? Who knows what EDI is? Awesome. 1, 2. Sir, I applaud you because you went through something that a lot of people won't have to. Electronic data inter-exchange. If you think JSON is like bad or XML is bad, try Googling for EDI. That's some really hardcore stuff. So, find any parameter, change it, see what happens. Especially useful if you have 2 accounts and you can change stuff between accounts, how authorization is being handled between accounts. What usually gets forgotten? Well, what happens if you have the same endpoint and then you add a parameter like export CSV or export PDF? In my experience, these are the parts where we have something that's like brittle authorization enforcement. If this didn't work, if you add the parameter, a lot of times the authorization will be bypassed. And you can, of course, then you can dump other endpoints, you can do all kinds of stuff. Layered logic is a brittle point for authorization enforcement. Remember that. Check this. Also, some resources that weren't available can suddenly become available, especially for endpoints that don't support this parameter. So you take a valid parameter and you issue it to an endpoint that doesn't support that parameter. But sometimes that endpoint will simply become available immediately. Going with that forward, you can also ask yourself multiple things. What happens if you send partial data? What if you remove a certain part of a JSON request? What if you add some data? What will happen? Usually interesting stuff. Business logic here is the key. Think what will break the business logic. And if you think this is difficult for attackers to detect, no, it's wrong, because the attackers can use something called an intercepting proxy. What's that? So you have a browser, you have an intercepting proxy like OWASP, ZAP, or Burp, and you have your page. So you log into the website with as user B, you store the JWT token or the cookie, you enter it in something called authorize, and then you just simply log out and log into the site as user A. And then you start browsing the site. You click on the links, you check out stuff, you can issue any kind of request, you can even manually change the requests in those tools. So you can see like the live site, you can see raw HTTP request responses, and for every of those requests you issue, there will be another request issued with a different JWT token or a different cookie. So it's like cruise control for authorization breakage. And then you will get a site. This is for user A, and for user B, these are the parts that it thinks that authorization is broken. This is actually a very good API endpoint because only half of it is broken. Usually, the other part is just red. That means everything is not enforced. So just think about that. Think about authorization. Another common problem here is what happens if, for instance, you have an API endpoint and you can get information about the user. It will tell you something like, okay, sorry if this isn't correct, but it was like written just to illustrate a point, but you have like a user, username is Kisasondi, email is Tony, password is Hunter2, admin is false. And then you go to change your password, and in the password change field, you shouldn't be adding anything else, like the original request is email, password, password confirmation, and that's it. What if you add an additional parameter, admin equals true? A lot of the times what you'll see in the source code, people will just simply do for every element in the request, just simply apply it. It will apply the admin is true also. So this is a thing you have to think about. This is called mass assignment, and it's way more common than you think. It's in top 5 or top 6 vulnerabilities for APIs. There are a couple of ways you can fix authorization. Some of them I quite like. One of them is Apache Shiro, which will integrate nicely in your Java and Spring project. It will work flawlessly. The second one is pretty new and hip and cool. It's called OpenPolls Agent. It's written in Go. It's part of the Cloud Nation set of tools and the Cloud Nation Foundation. It integrates nicely in Kubernetes. It works with Docker, so you can also do authorization on specific parts of your Docker's use case, so you can like prevent deletion, allow viewing of only some containers and so on. You can use it to secure HTTP APIs. You can use it to secure specific Kafka topics. So if you run Kafka, does anybody run Kafka here? Couple of people, not too much. Awesome. So if you run Kafka and you like Kafka, check this out, because this will, you can then gradually like have a fine-grained authorization level on any Kafka topic. This is something that is usually, Kafka doesn't have, but with this, it goes on pretty easily. You can use it to integrate with SSH. I mean, it's not with SSH, it's with libpum, pluggable authentication modules. So you can have authorization enforcement for any number of hosts that support SSH. You can use it to do authorization of specific parts of Terraform. It's interesting. And I like it, it's awesome. So how does Shiro work? Shiro works in a couple of ways. This is pretty much the examples you would get on the documentation, like the basic one. You can have like a permission-based authorization. So for any endpoint, you can just say, okay, if you have the permission to create an account, then you can create an account. You just label everything up, and when you have a user, you can just give it the labels it can use. Also role-based. You can say, require the role of teller, and then you can open an account. So you get some very good flexibility here, and you don't have to think about specific user types, specific user groups. You can just simply think in the context of labels, or you can think in the context of roles. But what Shiro does very well, that a lot of other things don't, other projects don't, is something called instance-level permission checks. So you can add objects and labels and inherit them. So for instance, you have something like Winnebago, you drive Eagle 5. So you are permitted to drive, so operations drive, the Winnebago called Eagle 5. But you are not permitted to drive the Winnebago called, I don't know, fire hydrant. So you can have a very rich set of authorization permissions, layers of labels that need to be satisfied in order for a certain endpoint to become available. And the great thing here is, you can, what is the default context for authorization? This is a big bane of authorization today. By default, everything is available, and then you block something that shouldn't be available. Here, everything works in a different way. Nothing is available. You need to make it available explicitly. So even by testing, you will see what's okay or not by testing that stuff. There's another cool tool called OpenPolls Agent, I talked about it, which has a different method. So you need a policy. They are heavily inspired by Go. You can just tell it default allow is false, so we're not allowing anything by default. You have a get method, and for any salaries, if the employee ID equals the user, then you can access salaries. You can access only your salary. For get input path salaries for any employee ID, you are allowed to do that if the input user is the manager of that employee. If you're the manager, you can see his salary. Everything else doesn't go. You can see only your salary, and your manager can see your salary. So it's pretty simple to write policies, and they can be reviewed. Because, for instance, when you have something like that, this is packed into a slide. But normally, when you read a policy, it will be way clearer, way nicer, and you can review them. You can see what's okay, what's not okay, and so on. And this also works. OPA doesn't integrate directly in your application, so it's not a library, it's a microservice. So you can run it inside of your infrastructure. Yes, and then you can secure Kafka, SSH, you can secure a lot of stuff. And simply issue a request to a specific endpoint for auth_z, give it a piece of JSON, which is the username, which path list do you want, which kind of method do you want, and then simply do a post request, and the response will either give you allowed or denied, and you can make your authorization check like this. So you can centralize authorization in an entire infrastructure regarding that. A common also misconception I see is people using JWTs or JOTs or however do you want to call them, 500 people, 500 different opinions. So what are JWTs? First off, you have a header, which will tell you what kind of algorithm is used for signing, and that's a JWT token. You will have a set of claims, like the subject, the name, and any other type of claim you can do. Every part of that header is base64 URL encoded, separated with a dot, and then signed with a specific algorithm, either HMAC SH256, RSA, which HMAC 256, or whatever your specific library is using. What are the common failures there? First, very common one is people use the wrong kind of storage for tokens. A very common wrong storage is local storage. Why? It's easy to access the token that way. Either you use a header or you use a cookie. If you use a cookie, then you can use the cookie flags that can protect the token against some types of attacks like XSS. If you use the header, then you are still vulnerable to XSS attacks, but at least you don't have the problem of cross-site request forgery. It's a trade-off. You can pick whichever you like. There are algorithm confusion bugs, which are dependent on what are you using in your library. And there are other issues like signature stripping. What happens if you just simply remove the signature? Well, one application that decided to implement their own JWT workflow had a problem that, for instance, when you strip the signature, it still accepted the claims. But if the signature was wrong, it told you wrong signature. But if there was no signature, it would just simply pass the token and say it's fine, right? Logic issues, bad keys, like weak HMAC keys, invalid recipient attacks, and same recipient attacks. How many of you use JWT tokens in the audience? How many of you know about those two types of attacks? Okay, you because you work at Auth0. And who else? Nobody. So microservices are great, but in a distributed system, it is very easy to screw up logic. How do you handle out-of-order requests? Just think about it. What happens if, for instance, I need request A, request B, request C? What happens if somebody changes the ordering for those requests? What if requests are sent to different microservices? What if they're sent out of order? What if they have partial content? What if they have extra content? Extra content is always amazing and fun. What if somebody, this is one of my favorites, called request smuggling. You have one HTTP request, and then you glue another HTTP request below that one. What will happen afterwards is that some systems will just simply execute both requests. Depends on the library, depends on the framework. Usually, a famous answer I got for this one was, who pastes two HTTP requests together and sends them as one? Well, I do. It's fun to do request smuggling always. Where do we fail here? Because when you think about microservices, when you think about your infrastructure, then you have a workflow you think that should be followed, but what you think is not what's enforced in your infrastructure. So what happens if an attacker breaks that workflow? Well, if you, for instance, use the same JWT token, but send it to a different microservice. So here's a common scenario. You have an authorization server that gave you a JWT token. It's valid for a single organization. You can use it for an organization one. But for instance, you start using it for a second organization. Like you have TLD something, and you have like a subdomain, but you use it for a second subdomain, like a partner organization that uses the same authorization server. There are quite some good examples of this, but I cannot go into detail, but you get the point. Just simply use the same token on the different organization that uses the same authorization server. A very common example here is something called what happens if you use the same token on a different subdomain or a different microservice. This is a very common mistake. This happens all the time because people think, oh, I secured my API endpoint, but everything is good, but what happens if you use the same authentication token somewhere else? Stuff breaks. And this is not, the problem I have with this is very simple. Do you remember what I told you about the attacker's superpower, reading with comprehension? This is not some magic hacker voodoo that like only specific hacker people go into a basement and then exchange those secrets. This is all widely known. So I didn't know some of that stuff before I was like, oh, JWT tokens. I need some good reference on like deploying and designing JWT tokens. So I went to Auth0. They have like a JWT handbook, which is freely available, 200 pages, and read it from one end to the other end. And they have a nice chapter with 30 or 40 vulnerabilities called JWT security failures. And then you try them and you see like it's correct, they work. Read the manual. It helps. Trust me. I know people don't like reading lessons or reading assignments. Lectira is old nowadays, but still it helps a lot. Should you use JWT or JWT tokens, however do you want to call them? Yes, you definitely should, for transitive identity verification. Microservice architectures are extremely difficult if you don't use JWTs. But also, think about tracking, managing, invalidating sessions. Think about invalidating stolen tokens. What happens if you want to deliberately forbid a simple one token from being able to use the entire infrastructure? Start thinking about the zero trust network principle. The zero trust network principle is pretty good. It will help you to design your systems in a way to be more and more resilient. Make sure that not one thing is a single point of failure security-wise in your infrastructure. Don't assume perimeters. Perimeters don't exist here. Conclusion, and the reason why I have a job in this world and this universe is because the way you parse logic and the way parsers and computers parse logic is way different. And this is one of the great roots of security. Read the manual and best practices. Please, I know it's difficult. It's usually 50, 100 pages. Especially go for the security chapter, you know? It doesn't stink, really. If you take a service, if you have something like Kubernetes, if you have something like Docker, if you use something like, I don't know, AWS, read what's IAM, like what's identity and access management, what you can do there. Things, you can save yourself lots of headaches later on. One good thing that I pitch all the time is there is something called ASVS, OWASP's Application Security Verification Standard. It's literally a free resource with some 50 pages of requirements. You have 3 security levels. Cursory, that means this shouldn't go on the internet without this being done. Standard, we consider this the standard of security. And the third one is advanced. And you have a checklist of stuff you need to do in order to make your service, application, whatever, compliant to a specific level. And also, OPA is amazing. Check out the OPA examples. Okay? Questions? "38 minutes, 21 seconds. We are open for questions. Please rate this talk if you liked it. You can troll me whatever you want. You weren't joking about the tomatoes.
Huh? Ah, this works. Okay, great talk. Question for the people who use computers less and less, like traditional laptops and computers, and more are on mobile devices and tablets. What do you do for U2F and like hardware tokens? What's the situation there?
The situation is pretty simple. FIDO2 keys support NFC. So you can just like tap it on the back of a tablet or a cell phone and it will work.
Cool, thank you.
Hi. Here, great talk. Question about SSO in general. Is it out of the scope of this, or what's your opinion in general about this, and how vulnerable that is or isn't?
There is nothing is vulnerable per se, or nothing is bad. This is also a pet peeve. I forgot to say this during the talk, but usually my blood boils when I hear on security conference people saying users are idiots because they cannot secure their stuff. But for instance, when I look at some of the infrastructure we have around two-factor authentication, securing some stuff, securing operating systems in general. Like if my mom cannot do it on her own, then as a security and development community, we're doing something very wrong, very badly. So accessibility should be way better there. What I think about SSO is I think it's really good as a concept, especially when you look at FIDO2, which will give you something like transitional verification. So for instance, I can just tell you, yo, I want to use Google for this, and 2FA from Google should be also used for this specific site or service and so on. It will be okay. But unfortunately, if you use a service, then you, as Master Yoda would say, your destiny is tied to their destiny. And if you roll your own, then I hope you know what you're doing. There is some good use there. There will be some also interesting developments in part of web authentication and so on. There is a talk about this later. But all in all, your mileage may vary. What can I tell you? If you do it on your own, please do read the security documentation. Make sure that you did security pretty well on that part. And if you're using a third-party service, keep in mind that you are dependent on them and them working, right? Next, there was a question here.
Hey, I have a question about refresh tokens. How do you handle JWTs and how long you want them to expire? Or?
Depending on your business need, your perception of risk. So there isn't a correct answer for this because like everything in security, if somebody from security tells you, you cannot do this, that's a wrong answer immediately. So when you say you cannot do this, you're being blocker to sales, you're being a blocker to business. But the correct question would be, what is your risk profile? Like an hour refresh token can be okay. A 30-second refresh token can be okay. How paranoid do we need to be about this service? When do you want to invalidate users? Will you issue a refresh token on any request? So an hour in general, sure. If you need something more paranoid, go with less. If you want something more friendly, go with longer. Did I get your question correctly? So you shouldn't ask how long, but you should ask how paranoid. What is your default use case for your clients? What do your users do? So always ask it's called, like certain startups call it turpentine. Like how are users using this? What's the use case? What do they have as a pet peeve with this? Yes.
Hi, I may have missed this in the talk if you mentioned it, but what's your opinion on push type 2FA like Duo?
Like Duo, amazing. Push type 2FA is also a very good business model for uses that don't want you to have FIDO2 and so on. So I would rank it, if you would ask me FIDO2, it's amazing, it's a new hotness, WebAuth and all of that is new hotness. But Duo has an amazing part in infrastructures, like in companies, especially if you have a big company and you want to roll your own. If you ask me, I don't want to be dependent on a third party, I want to roll my own, I would go with Duo. Yes, if that's the question. I like them, I like their services, I like the research they're doing, I like the way they're investing in some certain types of research, so this is a good choice if you want push type. Also, Google is doing certain types of push notifications with Duo style. So you get, if you have Google, an Android phone, they won't ask you for TOTP, they will just give you a prompt. Do you wish to authorize this? And iOS also, Apple does this. If you have one OK device, you can always use that. It's also good. Yes, there's a...
we have time for one more question, which is with the colleague there.
Sorry, I have a microphone, sorry.
Yeah.
And then you can find Tonimir afterwards anywhere in the webcam.
Listening.
Okay, it's not maybe on topic for this talk, but what in general security you think about Google allowing so many unpatched Androids existing?
What about all the unpatched machines running in God knows where, in the infrastructure of God knows who? It's the same thing. You cannot patch everything. The thing is getting way better currently with the newer versions of the software, and the whole ecosystem is getting way better. Even iOS and even even Android. So both ecosystems are doing pretty well. The current list price for a full compromise for an Android phone, like from I send you an SMS or you visit a page or something, so I can compromise your entire phone, the current list price for that is something like $2.5 million or euros, who cares on that scale. But so security is way up, and I would say like a modern iOS device or a modern Android device is pretty much the most secure computer.
So that's for the patched, up-to-date versions, right?
Yes. The newer, the better. And that's why I always, like, if you're asking, should I use this or that, I would use always the mainline stuff. The mainline Google, it's called Android X, I think. So anything that's following the current state-of-the-art, current patches, when you get patches day by day or month by month, iOS also, okay? You can bug me later, it's a break time. Thank you.
See you guys in half an hour, there's a break now.